Chapter 3 Understanding Quadrilaterals. Let's see the introduction of this chapter. On your page, without taking your finger, whatever you scribble, it's a curve. Now, it's a curve. This is a curve. Open and closed figure. Open and closed curve. This is a figure shape that's starting from this point and you are ending at the same point, that is starting point and ending point is same. In your closed curve, starting and ending point will be same. In open curve, the starting point and ending point will be different. You are starting from here, then you are ending at this point. So this is an open curve. Simple closed curve. A closed curve that does not cross itself is called a simple closed curve. Simple closed curve means it's a closed curve that does not cross itself. See, this is a simple closed curve. This is a simple closed curve because does not cross itself. See, look at these. These are also closed curve but not simple closed curve. These are complex curve because crossing itself. You can see that intersecting point. These two are same shape. I mean like a star. It is looking like same polygons. But the difference, this is simple closed curve because not crossing itself. This is complex curve because you can see that intersecting, crossing itself. So simple closed curve means does not cross itself. Let's match this one. The first one, simple closed curve. Simple closed curve means it's a closed curve, does not cross. This is not a closed curve and this is crossing itself and this also crossing itself. Simple closed curve means what? Does not cross. So this is a simple closed curve. Then a closed curve that is not simple. This is not closed. This is not closed because starting and ending point is different. Because it's starting here it is starting, here it is ending. So this is not a closed curve and this is a closed curve but not simple. It's not simple closed curve because crossing itself. So this is the right answer, a closed curve, not simple. Then simple curve that is not closed. Simple curve that is not closed. Okay, here these two are there. Simple curve that is not closed because it is a simple curve. Simple curve means what? Does not cross. Keep in mind. Is it crossing? This figure is not crossing. It is not intersecting. So it's a simple curve but not closed. Is it or not? It's an open curve and not a simple curve. This is not a simple curve because crossing, you can see that intersecting, so not a simple curve. So finally we conclude a simple curve is a curve that does not cross itself. Simple curve means what? Does not cross itself. Okay, let's go to the polygons. A simple closed curve, which is made up of only line segment is called a polygon. Poly means many, gon means side. So many sided shape, that is called polygon. See, these are all polygons. A simple closed curve which is made up of only line segment is called a polygon. Poly means many, gon means side, many sided shape. So the polygon must be bounded by only line segment. Polygon must be bounded by only line segment. Example, this is not a polygon. Could you see any line segment here? No. So this is not a polygon. Even this also not a polygon. So polygon means what? Many sided. That is, polygon, the shape which is bounded by only line segment, is called a polygon. Diagonals. A diagonal is a line segment. A diagonal is a line segment connecting two non-consecutive vertices of a polygon. See, this is a polygon, four-sided polygon, because there are four sides and the vertices are P, Q, R and S. The vertices are P, Q, R and S. Diagonal means these dotted lines are called diagonals. That is, a diagonal is a line segment connecting two non-consecutive vertices. Consecutive means what? Continuous, very next. So consecutive means very next. That is P, vertex P. Consecutive vertices are Q and S. But here diagonal means connecting two non-consecutives. So if you take the vertex P, the non-consecutive vertices are only. We will leave the consecutive vertex. Non-consecutive vertex only are connecting. So PR is a diagonal and another diagonal is SQ. Likewise, in this figure also, in this polygon also, you can find the diagonals AC, that is connecting two non-consecutive vertices. If you take vertex A, the consecutive vertex is B only, but diagonal means what? We have to connect the non-consecutive. So we leave this consecutive vertex and the next one, no, that is C. So we are connecting, that is two non-consecutive vertices you are connecting. So AC, comma CE, then comma EB, then BD, DA. These are diagonals of this given polygon ABCD. So here also we can find the diagonals. KM is a diagonal and LN is a diagonal because connecting two non-consecutive vertices.